So in this video, we're going to talk about hydrogen sulfide, right? H2S. Is this molecule polar or not? It's a very interesting molecule. Well, the first thing I'm going to do is figure out how many electrons I have to place to get Lewis structure correct, right? So we know that from the periodic table, sulfur gives us 6 electrons, and this is an ugly writing. But we know that from the periodic table, sulfur gives us 6 electrons, so we have 1 sulfur atom, and we know that we have 2 hydrogen atoms, and each hydrogen gives us 1 valence electrons. So what I'm doing here is just to calculate the total number of electrons I have to place, so that way I have to double check my Lewis structure to make sure that my structure is correct. So in this case, 6 plus 1, 6 plus 1 is obviously 7, but remember that we have 2 hydrogen atoms, so it's 2 times 1. So in fact, we have a total of 8 electrons that we have to place. So again, usually when drawing Lewis structures, the atom furthest to the left of the molecular formula, not always, is usually a central atom, but this is actually an exception, right? In this case, we have hydrogen that's furthest to the left, and we know that hydrogen can only form 1 bond, so therefore it will never kind of be your central atom. So in this case, we only have one option, which is to put the sulfur. In this case, we have 2 hydrogens, so we could go ahead and put the hydrogens around the sulfur atom. In this case, we could just form single bonds starting upwards, right? So in this case, we have 2, 4. We have placed 4 electrons around the sulfur. We placed 4 electrons around the sulfur, and so the sulfur's octet is not full. Now, hydrogen, interestingly, we cannot put any more electrons around hydrogen, right? Because remember, hydrogen only has 1 valence electron. It can only form 1 bond. So in this case, the only option we have is to put the rest of the 8 electrons that we have in this molecular formula on the sulfur. And we do this in the form of lone pairs. So this is actually the structure of hydrogen sulfide. Now, interestingly, because you have lone pairs on the central atom, the geometry actually shifts down. So these bond angles become closer to each other. And so if we actually draw the actual structure of the molecule, it appears as bent, right? So the molecule looks something like this. With or 2 lone pairs on the top, right? And so, is this molecule polar or not? Well, let's look at the dipole moments. We know that sulfur is more polar, or more electronegative rather, than that of hydrogen, and so we know that the electrons should be going towards sulfur in terms of our dipole structure, and the same thing should be on the other side, right? The hydrogen is partially losing electrons, the sulfur is partially losing electrons. Now, what we actually see here is that the dipoles are not going tail to tail, so there's no canceling out of dipole here, and so in fact this molecule is actually polar. And it's because of the lone pairs on the central atom. Alright, so sulfur, hydrogen sulfide is actually a polar molecule. Again, usually we said that if our dipoles are going tail to tail, something around this, then these will cancel out, and so we would have no dipole moment. But you could clearly see here that these dipole moments are going head to head, right? So they're not tail to tail, and so this is your classical polar molecule. So hydrogen sulfide is slightly polar.